Shahid, who is this? And Tariq only. Okay. So where is it is? Conversion basically. The first one is your aniline to chlorobenzene. How you are going to convert it? Very easy it is. Let me know if you are not able to solve this, how you are going to convert this. If any answer? No answer. To see
Yes,
how
I got it.
aniline, first of all, you should know the structure of aniline. and you need to prepare chlorobenzene. This is your chlorobenzene. So first you are going to treat this with NaNO2, nitrous acid, basically NaNO2 plus HCl. The temperature should be cold, like 0 degrees centigrade to 5 degrees centigrade. So what will happen? Basically, there will be formation of benzene diazonium chloride, that is N2 plus Cl minus. This is a salt which has a name benzene.
We're using Sandmias, right?
Yeah, Sandmeyer's reaction, very important and important name reaction. And after this, you are going to react this with Cu2Cl2. Then you will be getting chlorobenzene. Very easy, isn't it easy? Please do write it. The next I'm going to give you is 2-chlorobutane. From you are going to prepare 2-chlorobutane to 3,4 dimethylhexane. So if you have studied all the chemical reactions in haloalkanes and haloarenes, it will be very easy to predict the product. Shahid, are you getting my point? Have you studied Sandmeyer's reaction? This is your Sandmeyer's reaction. See 2-chlorobutane and this is your 3,4 dimethylhexane. Okay, very easy. How many number of carbon is there? Hexane, that means 6, and 2 methyl is there. So total number of carbon is basically 8. And how many carbon is there? 4. So Wood's reaction. It is your Wood's reaction. What you need to do? Very simple. Very good, Harif. So 2-chlorobutane. So what I'm going to do, CH2, and I'm going to write this and then CH3. Reacting this with 2 sodium in the presence of dry ether. You know how the reaction will take place. I'm going to actually show you how you can feel it is very easy. Only the way I'm going to write this in this way: CH3 and then CH2, and then comes your CH, and then there is Cl, and then there is CH3. and then I'm going to write 2Na. And actually in Wood's reaction, we need 2 mole of this. So another mole of this, I'm going to write it in image form, image, just the image of this. You can see left will be written right. Now, what you need to do, it's very simple. You can see, you just need to remove this NaCl and add this carbon to this carbon. What you will get? First, I'm going to write from here in the presence of dry ether, CH3, then comes your CH2, then comes your CH, then this CH will be directly connected with this CH, and then comes your CH2, and then comes your CH3. This is your CH3, this is your CH3. Okay, now if you're going to name it, very simple, 1, 2, 3, 4, 5, 6. We need greater number of carbon as skeleton and branches as well. So you can see 3, 4 dimethyl it is. 3, 4 dimethyl, and this is your hexane. Isn't it easy, Shahid?
Yes, sir.
Please do it. Let me know when you are done with this. Are you done with this? Shahid, Shahid, are you done with this? So we are about to complete Shahid the conversion. Then we will go. We will start alcohols.
Sir,
Yes.
can you just scroll up? I'll just take screenshot.
Okay, you can go. We started from here. Aniline.
Yes, sir.
And then 2-chlorobutane.
Yes,
And then I just gave you this question. Let me know if you're not able to solve this. You just need to write the structure of this, and then try to connect how you can prepare this.
So I can use a HBR here, sorry, HCl.
HCl or HBr? Which reaction do you name it HCl now?
Marconic.
Yeah, you can use that. Yeah, both of you, Shahid and Savage. So I'm going to write the structure first. Propene and 2-methyl this is. From here you want to go to 2-chloro, 2-chloro, 2-methyl, 2-chloro, 2-methyl propane. So if you want to do this, yes, Savage, sorry, Tharif. Now what you need to do, very simple. You can use HCl, Markovnikov. You know that Markovnikov says what? Negative part, HCl has two parts, H plus and Cl minus. Negative part will go to that carbon which has lesser number of hydrogen. And so in this way you can easily prepare. Isn't it easy?
Is
Okay. The next is butene to butyl iodide. Very easy.
Sir, I did.
Very good. So it's, I think, very easy. Shahid and Arif, are you able to do this? Butane, first write the structure. CH3, CH2, CH double bond, CH2. You can keep the double bond between this as well. That is also this. And you want to prepare butyl iodide, that means CH3, CH2, CH2, CH2 iodine. So how I can prepare it? So whenever alkyl iodide is there, there is a name reaction, Finkelstein reaction. So what I'm going to do, I'm going to react this with HBr in the presence of peroxide, This says anti-Markovnikov. This is what? Anti-Markovnikov. And what is anti-Markovnikov? You know that this will have H plus and Cl minus, and according to anti-Markovnikov, negative part will go to that carbon along double bond, which has greater number of hydrogen. This bond will be broken. Now what you will get? You will get CH3, CH2, and then again CH2, one hydrogen added, and here it is CH2Cl. After this, what you need to do, just react with sodium iodide in the presence of acetone. So what you will get, basically you will get this. Basically this chlorine will be replaced by iodine, and you will get iodobutane or butyl iodide. And as a byproduct, you will get NaCl. And this reaction is basically known as Schwartz reaction. Do you remember Savage you did? Shahid and Arif. Okay.
Sir, can we just, instead of Cl, can we just do PRN to Finkelstein reaction, like do it NaI and get NaPr?
I didn't get it. This
Sir, instead of Schwartz reaction, just can we do Finkelstein?
Finkelstein is especially for fluorine, fluoride. Are you getting my point?
Yes, sir.
Finkelstein is a space. Wait a minute. Schwartz or Finkelstein? I'm just getting confused. Wait a minute. Schwartz, I think, is. Just wait a minute. No, the name I have written wrong. The reaction is correct. Its name is Finkelstein. The first one is Finkelstein. Thank you. I got it wrong. Okay. The name of this reaction, especially for iodide, we are going to name it. Its name is Finkelstein reaction, not Schwartz. Okay. All of you. Thank you, Tariq. Okay. The fifth one is also. You are going to do the fifth one. 2-chloro-propane to 1-propanol or propane 1-all. Let's do this.
Sir, I was having a doubt.
Yes, tell me.
Sir, here like in anti-Markovnikov, we cannot use HI.
No, we can use, but there are some conditions generally we use. And wait a minute, where I am. You can see as HBr I used here, so we should write Br here, not HCl. Where is my mind? So we used, oh, this is the mistake where I had done. HBr is there, so there will be Br negative. So here it will be Br, and the rest part is clear. Correct. There are some conditions, Savage. Reactivity we can do also by that. Directly we can get, not a problem.
Yes, sir.
Let me know when everyone is done with this. Very good, Tariq. Any answers, Shawez and Shahid? I'm going to explain this. First, you need to write the structure. 2-chloropropane. That means this is the structure of 2-chloropropane. And 1-propane also. This is what you need to prepare. So what I'm going to do, I'm going to react this CH3, CH2, sorry, CHCl and CH3 with alcoholic KOH and heat. So what will happen? Beta elimination will take place. Cl and H will be eliminated. So it will become this alkene. After getting alkene, what I'm going to do? I'm going to react this with HBr in the presence of peroxide. So that Br will be at last carbon. So we will have CH3, it becomes CH2, and this is your CH2Br. After getting bromine, what I'm going to do? Again, I'm going to react this with aqueous, basically aqueous KOH and heat. Aqueous KOH OH will replace this and you will get CH3, CH2, CH2 and OH. This is how you can get this. Is this correct, Arif?
Yes, I did this.
Very good. Please do let me know when you are done with this. Everyone is done with this. Chavez. The next is very easy. I'm gonna give you very easy. This question I'm expecting from everyone. Chloroethane to butane. Very easy it is. Good reaction. Very good, Shahid. So it's very easy, right? Chloroethane, that is CH3, CH2, Cl. You are going to react this with sodium in the presence of dry ether. It will be double. 2 carbon will be converted into 4 carbon. So this is how it will be. Very good. Three more conversion is there, then we will start alcohol. Benzene to biphenyl. Very easy it is. Please do it. Biphenyl is double phenyl basically. Biphenyl, if you want to draw the structure, this is what biphenyl looks like. Very easy it is. Yes. Yes, exactly, Tariq.
Its reaction.
Very good, Shahid. Savage, no reply from you. So benzene it is. I'm going to write the benzene first. First, what you need to make is uh, chlorobenzene or halobenzene, basically. Arene you need to make, haloarine. So this is your benzene. So first, what I'm going to do, react this with Br2 in the presence of FeBr3, which is an electrophilic substitution reaction. Due to this reagent, there will be generation of Br plus, and this Br plus will attack on benzene ring. You can see this is. Now, after becoming Br, you are going to react this with 2 sodium in the presence of dry ether. This is a name reaction which is fatigue reaction. You know the name of this reaction, that is Wurtz. So what you will get, biphenyl, double of this. This is your biphenyl plus 2 NaBr is that. Is that clear? Let me know when you are done with this. Everyone is done with this. Shahid, Shavez. The next is tertiary butyl bromide, and we are going to convert into isobutyl bromide. Very easy it is. Are you done with this? Very good. First of all, butyl, that means 4 carbon total, and it should be tertiary. That means 3 degree. So this is your tertiary butyl. And isobutyl, that it should be secondary. So you need to convert into this CH3, CH, CH3. This is your isobutyl. Secondary carbon is there. Now, how you are going to convert it? It's very simple. First, you are going to react this with alcoholic KOH. That means dehydrohalogenation will take place, beta elimination will take place. Then you will be getting Br removing from here, hydrogen from here. Anywhere you can remove. So this will be C double bond, CH2 it becomes, and CH3 was there. After this, what you are going to do? HBr in the presence of peroxide. So this bromine will go here and H will be here. So it becomes CH3, CH, and here it becomes CH3, and here you can see it is CH2Br. Now you can see this and this are same. So basically, this is how we prepare this.
Sir,
Yes.
here isobutyl means bromide is attached to secondary carbon, right?
Yeah, this is secondary and this is tertiary. Basically, ISO is like this. Okay. This is your ISO. Is that clear?
Sir, like that is not secondary, right? That which Br is attached.
Yeah. What happens into the secondary? Secondary butyl will be something else. That is secondary. This is your primary. If you are seeing with respect to
Okay,
this,
okay.
it will be primary. This is tertiary butyl. That means basically the bromine should be tertiary. So this is tertiary connected to this. Isobutyl bromide, that means in this isobutyl, there must be a carbon which is secondary. And there is valency free here and it becomes 1 degree. Okay. This should be clear because
Okay, sir.
examiner will ask this type of question. Definitely. Let me know when you are done with this. Everyone is done with this.
No, sir,
What did you say?
sir,
Okay. Can we move to the next chapter, that is alcohol?
sir, I didn't complete.
Savis, what did you say? I'm not able to get you.
Sir, I didn't complete.
You completed, right? You can reply in chat box if there is noise. So everyone knows how to calculate the degree of alcohols, right? Oh, you didn't complete. Sorry. I thought you told me you completed. Please do complete it. Yeah, basically, Tharif, if this basics reactions, which are not so basic, some of the reaction is very good. If it will be clear, then you will
Yes,
be
sir.
able to solve the conceptual question. Okay, Tharif.
Yes, sir.
So just wait a minute. Just wait a minute, please. Hello, can hello, right? Almost over. Okay. Actually, I forgot to give you some PYQs, previous year's question. I thought I already completed that. So here is your first question. Shahid B. Why B? Arif, can you explain your answer?
Yes, sir. Can you hear me, sir?
Yes, yes.
Okay, sir. So in an SN1 reaction, yeah, like in an SN1 reaction, like there's a stable carbocation and
See
the
what happens basically. There is formation of the carbocation in the first step, R1, R2,
yes, sir.
R3, let's say. Okay. So back attack and front attack both can be done with nucleophile, and due to this you can see 100% racemization will be there, right? but
Yes, sir.
but this is not 100%. There is no 100% probability that if back attack is happening, that means inversion is taking place, and if front attack is taking place, that means retention is taking place. But it doesn't mean that it is 100% sure. So it is not 100% true for a probability. If anyone will be more, let's say inversion more than retention leading to partial racemization. Basically, what I want to tell you is that it is not 100% sure that 50% racemization, 50% inversion and 50% retention will take place. It might be like retention is greater than inversion, and inversion is greater than retention. That's why partial racemization will be there. Is that clear, Shahid? Okay. Oh, very good, Tariq. Any answer from Chavez and Chavez inside? Very good, Chavez. So see what you need to do. It's very simple. Two possible stereo structures of this, which are optically active, are called in enantiomer. If you are going to draw the structure, it will be CH3, CH, and OH, and then there is C double OH. This is what chiral. Then mirror image is non-superimposable mirror image, non-superimposable mirror image, and hence it is called enantiomer. Is that clear, all of you?
Yes.
Very good. Hmm. Oh, no, wrong answer. So see, if you are going to calculate this, it's very easy. Just wait. Okay. So first of all, which of the following compounds will undergo racemization? We need to look for the chiral carbon. So this is not your chiral. If you're going for this, this is also not your chiral. This is also not your chiral. This is chiral. Okay. But this option is also 4 is also given with 2, which is not chiral. 4 is also given with 1, which is not chiral. 4 is also given with 3, which is not chiral. So none of these are correct. Okay, alone this will have the racemization. Are you getting my point? Very good. Just wait a minute. Okay.
So for this question, there will be no marks.
No, it will be in bonus basically. Now going towards JEE mains paper. It will be bonus. That means everyone will get. So this question you can easily do it. Basically, just wait a minute. Did I give this question? Okay. Basically, if you're going to see this question is from alcohols, but in haloalkanes PYQs, in PYQs book, it is given in haloalkanes. Can you tell me which is what is this basically? This is your propene. So I'm going to write CH3 CH double bond CH2. If you have studied alcohol, you are going to do the hydrolysis. That means hydration in the presence of acid catalyzed. So you know that it will follow what? It will follow basically Markovnikov, and you will get CH3, CHOH, and then CH3. After this, what it is using KIO in the presence of dilute KOH, which means basically iodoform reaction is taking place. So this whole quantity, you can see, this whole quantity will be oxidized. And secondary alcohol, this is basically oxidized into carboxylic acid salt. So it will be oxidized in this way. And a byproduct will form, that is CH3I. This carbon will directly form iodoform. Now what it is? Iodoform. So this is your B and this is your C. Basically, that's why I was avoiding this type of question, because in JEE Mains, most of the questions I have to omit from there. Most of the question will be mixture of all the reaction. Here you can see this question is from alcohols, right? And then it uses this reagent which you will study in aldehyde and ketone. Are you getting my point, Savage and Tharif?
Yes, sir.
Please do it. Let me know when you are done with this. Just wait a minute. this? Tarif,
Yes, sir.
are you done with this question?
Yes, sir.
Okay, so this is it for today. I will give you more question in next class. I have to leave because something urgent came up.